Good evening. So we're looking at assignment 4, questions B3 and B4, tips. So question is B3, it's the top right hand corner. Use board adhesions to determine the sign properties of the following constrained quadratic forms. So B3A, what do we have? We're given Q is x squared in B3A 2xy minus y squared, subject to x minus y is 0. Of course we can, well, it's asked to do that too. In this case we can say y is x, substitute it in Q, and then conclude that it's positive definite. But we're supposed to use the board adhesion. So, well, let's write down the board adhesion. We can do that immediately. So here we use A. And in this case, of course, M is 1 constraint, and N is 2 variables, X and Y. And then we have 1 minus 1 from X minus Y. So this is Hx comma Y. We can treat this as F, but and then we would get a certain board adhesion. But we can also treat Q as xt factor A x, and in that case, of course, we have a 1 here from the x squared, a 1 here, a minus 1 here from the minus y squared, and the 2xy splits up as 1xy and 1yx. 2m plus 1 is 3, n plus m is 3, so we need the determinant of HB. So that you need to calculate. And then look at the two rules for the classification. So the two rules are minus 1 to the power m, and then minus 1 to the power n, and in this case, well, that's all you need to do because we only need one determinant. In this case, you can also treat Q as F, but I wouldn't do that, but you can. And then HB, called HB tilde, is your, well, you could say 0, minus 1, 1. So minus 1, 1, and then it's 2x, so your x squared, we differentiate because 2x, this becomes minus 2, and here it's 2, 2. And then you still only need to look at, oops, that's not helpful, that's a bit too, oops, I'll write it down again, a bit lower. Let's see, we had it, yes, so HB tilde, you can write down minus 1, 1, minus 1, 1, and here 2, minus 2, 2, 2. If you use a Lagrangian, which is x squared plus 2xy minus y squared minus lambda x minus y, it gives you the same sign properties. So you can also look at that one. But it's easier because it's to look at the first case, but you can't only do that when you are given an actual quadratic form. So let's look at B2b. So and we need to do check. I forgot to say that we need to check in the previous case that in both that of course delta H is unequal to the 0 factor, so the NDCQ is satisfied. So B3b, we can have a pure quadratic form, so we can again write down, but now we have n is 3, m is 1, so 2m plus 1 is 3, n plus m is 4, so we need LPM 3 and LPM 4 for the classification. So now you need to look, when you apply the two rules, you likely need to look at whether the LPMs are the same sign or have an alternating sign relative to the main determinant. So you need to write down HB, which will be a 4 by 4 matrix. That's the bordered Hessian. So again, since it's a pure quadratic form, you can consider Q is x of t ax, and then identify the x directly. In this case, at the end, you can say set is x plus y sub into Q and see whether you can spot that it is helping you to classify the quadratic form. In the previous case, we had y is x, so we can put that into Q, and then I think we got there we have, then you can draw a conclusion. So let's look at B3C. We have Q of x1, x2, x3. We have H1, which is x1 plus x2 plus x3 is 0, and H2, which is x1 minus x2 minus x3 is 0. So what do we have? We have n is 3, m is 2. So 2m plus 1 is 5, n plus m is 5, so we only need LPM 5. It's the determinant of HB. So HB, you need to write down, well, that's 0, 0, 0. Then if we just use H, or the gradient of 1, 1, 1, it's 1 minus 1 minus 1, 1, 1, 1, 1 minus 1 minus 1. And then with Q, what do we get? 1 minus 1 minus 1, 1 minus 1 minus 1, 2, 2, 1, 1, 0, 0. So we need to calculate the determinant of HB. So that's 0, 0, 0, 0, 1, 1, 1, 1 minus 1 minus 1, 1, 1, 1, 1 minus 1 minus 1. What was it? 1 minus 1 minus 1, 2, 2, 1, 0, 0, 1. We need the determinants, so straight lines. So how shall we start? Yes, so we add this row to that one. Then we get 0, 0, 0, 0, 1, 0, 0, 1, minus 1, minus 1, 1, 1, 1, 1, minus 1, minus 1, 1, 2, 1, 2, minus 1, 0, 1, 0, minus 1. Sorry, this gives us 2. So now we do this one times this one. So this is, it's an uneven spot. This is 1, 2, 3, 4, 5. So at the uneven spot, it's a plus 2 times the remaining determinant as indicated. So that's a way of doing it, right? There are several ways of doing it. So now, what shall we do? What shall we do? What shall we do? Let's see. What shall we do? Now it's easiest to. So this row was added to that first row. Now it's, so that's what is it? Row 1 is row 1 plus row 2, and here it's C1 is C1 plus C2, so that gives us 2, 0, 2, 0, 0, 0, 1, minus 1, minus 1, minus 1, minus 1, 2, 1, minus 1, 0. So there are several ways of doing it, but now it's this one times this matrix, etc. So that gives us a 4 times 0, minus 1, minus 1, minus 1, minus 1, 0, minus 1, 0, minus 1, and that's actually gives us minus 8, which is less than 0. And n in this case, n was 3, so minus 1 to the power n is minus 1 to the power 3, so that's minus 1. So that's rule B, and then A, and rule B holds. In A, it was minus 1 to the power m, which is minus 1 to the power 2, so that's 1, so this is not the case. So this one is the case, and therefore we have that it's negative definite. Just to give you, so that's the third one. So let's go to the last question, or last set of questions, B4. B4a, what do we need to do? Write down the Lagrange and hence find all the stationary points of the problem of the maximizing the function. So n is 3, m is 1. So step 1 is write down the Lagrangian with 1 lambda, which is fxy minus lambda h of x comma y minus 1 in this case. So that's step 1. Step 2 is write down the 4 FOCs. Right, so dl dx is 0, dl dy is 0, and neatly number them. dl dz is 0, and minus dl d lambda is 0, which gives you the constraint. Number them, solve them. Once you've solved them, we go to question B, which is look at the LPMs. So we will need to find the boarded Hessian, and then in this case 2m plus 1 is 3, n plus m is 4, so you will need to calculate LPM 3 and LPM 4 for the classification. Any tricks with the yeah, so the third equation, this one will give you, it's the easiest to give you the two cases. I think it'd be 2 critical points. For each critical point, you need to calculate the LPMs. You can do because the constraint is quadratic, part of the boarded Hessian will depend on x, y, z before you substitute in the stationary point. So you can either calculate with those, and then once you've calculated the LPMs, which will LPM 3 and LPM 4, they will necessarily be functions of x, y, z, and then you substitute in the critical point, or you calculate HB as at the critical points every time. So you can choose, but you need to evaluate them. So that finishes it for tonight. Good luck with the exercises. Let me know if you have any questions. Have a nice weekend.